If you're looking for a 14-bit 60 MHz 2-channel function generator that includes a wide range of waveforms and can save up to 64 custom arbitrary waveforms, then you'll want to take a closer look at the FY6900 from FeelTech. Have you ever found yourself situated in a paddock full of cows and need to order circuit boards? Yeah, me neither. But if I did, I would use this video's sponsor, JLC PCB. 5 circuit boards cost as little as $2. They offer fast production time, and with a multitude of design options, you're only limited by your imagination. Ordering is as simple as going to jlcpcb.com, uploading your Gerber files, and choosing your design preferences. You can also choose any colour solder mask at no additional cost. And if you're new to designing circuit boards, then check out my KiCad circuit board series to get you started. Look Daisy, free circuit boards. For anyone wondering, I paid full retail price, which at the time of filming was $92 for the 60 MHz model, and you can be sure this review and my opinion are unbiased. Included in the box is a USB cable, 2 sets of Bnc to alligator clip leads, a single Bnc to Bnc cable and power cable, and of course the generator itself. The kickstand is deployed by pulling outwards and folding it forwards, and locked securely in place. The rear I/O has trigger in, VOC in, sync in and out, TTL output, and a USB port, more on that soon, and lastly a C14 socket for power. At the front we have a 2.4 inch colour TFT display, channel 1 and 2 Bnc outputs, and a counter Bnc input. The tactile feel of the buttons and rotary wheel feels surprisingly good for this price point. During startup, the generator performs a self-check. The layout of the menu buttons is very intuitive. I found my way around the vast amount of options without ever having to read the user manual, which by the way is excellent. FeelTech obviously care about the end user by providing a comprehensive manual that is both well written and easy to understand. If you're curious about any technical specifications that I haven't included in the video, then you can download the manual from the link located in the video's description. By default, there is an audible chirp every time a button is pressed. If that bothers you, you can turn it off by pressing the System button, then Config, then pressing Buzzer to toggle on or off. You can also choose to have both channels on or off after startup by pressing System, then More, and here you can toggle the channels on or off after startup. The counter Bnc input has a voltage limit of 5 volts. To demonstrate this feature, I'll connect channel 1, which is currently outputting a 60 Hz sine wave, to the counter input, then press the counter button. The display then shows you various information about the waveform being measured. The buttons labelled channel 1 and 2 are used for selecting each channel, then by pressing wave, sweep or modulation, and then programming your desired frequency along with other waveform settings, you can program each channel to your exact requirements. Channel 1 and 2 buttons also allow you to turn on or off each channel. The buttons also illuminate green when the channel is on. You can choose from a comprehensive list of standard waveforms, or if that's not enough for you, you can program up to 64 custom arbitrary waveforms. To program an arbitrary waveform profile, first connect the generator to your PC via the USB cable, then download and install the free software from FeelTech's website. Click on Download, then scroll down until you find FY6900 User Guide and click on Download Now, which will take you to a Google Drive folder where you'll find the user manual and software. To download, right-click and then select Download. After installation and starting up the program, it automatically connected to my generator. The program offers full control over the generator, allowing you to program and control everything from your computer without the need to touch the generator. To program a custom waveform, click on Waveform Window tab. Here you can click and drag the blue line to create your arbitrary waveform. Select from one of the 64 profile slots, then click Send Data to save the profile to the generator. Alternatively, you can click on Text Window and type in the X and Y coordinates of your desired waveform, then save the profile just as before. Alright, now it's time to break out the oscilloscope and take a look at the output from the generator. I'll use the Bnc to Bnc cable to connect the generator to my scope. Here is a sample of 4 different waveforms, all at 60 Hz frequency. The waveforms look good with no obvious signs of distortion. Now let's look at 1 MHz samples. The sine and triangle waves look fine, but the square and sawtooth waves have a small amount of ringing. If I zoom in for a closer look, the issue becomes more clear. However, this is not caused by the generator, rather it's from the BNC to BNC cable, so I'll swap it out for my scope probe and retest. Now the square wave is looking clean with no ringing anymore. Alright, now let's pop the hood and take a closer look inside. The front and rear panels unclip with some prying with an old card. The front panel has a couple of connectors which you can unplug, allowing you to remove the front panel. After doing so, I noticed a warning label informing me not to remove until washed. You know, just in case you felt like washing your function generator. With the front panel removed, we can see there is a centre post that is secured by means of a screw that is hidden under the label. See you later, warranty. After removing it, the lid comes off. The main board looks well designed and all the SMD components look neat and tidy. The main IC is a Cyclone 4 FPGA, which besides being the brains of the system also has programmable storage on board. The second PCB is a switch mode power supply that is responsible for breaking down the mains voltage to 5 and 12 volts DC. There is also an input fuse located here. My only complaint is the wire connecting the earth pin from the socket to the earth connection on the PCB was not rated for mains voltage and could potentially short out in the event the wire touches a live connection on the PCB. Although the risk is somewhat low since I had already opened the enclosure, I opted to replace the wire with a mains voltage rated one. And with that done, the last thing to do was to wash and dry my PCB so I could remove the sticker before reassembly. If you found this video useful, please give it a like and subscribe for more future videos like this. Thanks for watching and I'll see you in the next video.